Welcome, my friends. In this video, we will discuss the mean, median, and mode, which are three measures of the average of a dataset. In statistics, the word average has a broader meaning than what you might be used to. To a statistician, an average is simply a number that describes the center of a dataset. The three most commonly used averages are the mean, the median, and the mode, and we will be talking about each of these measures in this video. First, let's discuss the mean. The mean is what most people think of when they think of an average. The mean of a dataset can be found by adding up all of the values and dividing by the total number of values. For many reasons, it becomes important to differentiate whether or not the mean was calculated using all of the data in the population or from a sample. We use the symbol x bar to represent the mean when it is calculated from a sample, and the lowercase Greek letter mu when it is calculated from a population. If we define a few more terms, we can come up with a more mathematically rigorous definition of the mean. Let x represent the data, let lowercase n represent the sample size, and let uppercase N represent the size of the population. Also know that the uppercase Greek letter sigma is a symbol that tells us to sum or add numbers together. With all of these pieces, we can come up with mathematical formulas for the mean. The sample mean x bar is the sum of the data, x, divided by lowercase n, and the population mean mu is the sum of x divided by capital letter N. These formulas really are just the same one that we introduced in words, except now they are more mathematically precise and tell us whether or not the data is from a sample or from a population. Let's take a look at an example. Suppose we have these 5 numbers and we want to find the mean. Notice that I'm labeling the numbers as x. This may seem a bit odd to you if you're used to an algebra class, where you often solve for x, and x represents only one number. In statistics, lowercase x typically represents data, meaning there are several different values for x. Sometimes we label them with subscripts, so we might have x1 is equal to 3, x2 is equal to 4, x3 is equal to 5, etc. But we won't worry about that here. To find the mean, it doesn't matter if these values are from a sample or a population. Either way, we need to sum up all the numbers and divide by the total number of observations. For notation's sake, let's assume that these values came from a sample, so we're using this formula. The numerator is the sum of all of the x values, which is 3 plus 4 plus 5 plus 9 plus 9, which equals 30. Lowercase n is the size of the sample, which is 5, since there are 5 numbers in our dataset. 30 divided by 5 is equal to 6, so our sample mean is 6. The mean is the most commonly used average for many reasons, but one reason is that the size of every number in the dataset is considered. If you change any single number in the dataset, the mean will change, which isn't the case for some other averages. This can also be a weakness of the mean. If there are a few very extreme values, often called outliers, they can change the mean dramatically. To see how, consider the same data, but now we have one additional number, 150. Now the mean is 3 plus 4 plus 5 plus 9 plus 9 plus 150 divided by 6, which comes to 30 when you simplify. The value of 30 is nowhere near any of the values in the dataset, so it might not be a very good representation of the center of the data. The next type of average we will discuss is the median. If the data is listed in order from smallest to largest, the median is the center of the data, the value that splits the data into 2 halves. To find the median, first order the data from smallest to largest. If there are an odd number of values in the dataset, the median is the middle number. If there are an even number of values in the dataset, there will be 2 middle numbers. The median is simply the mean of the 2 middle numbers. Here's the dataset that we looked at earlier when we calculated the mean. Notice that the numbers are already in order from smallest to largest, and that there are 5 observations, which is an odd number. To find the median, simply cross out the largest and smallest values until you have the middle value. First we cross out 3 and 9, then we cross out 4 and 9, and we are left with one number in the middle, which is 5. So the median is 5. If we have an even number of values, which we do with this dataset that has one additional value, there will end up being 2 numbers in the middle. Cross out 3 and 150, then 4 and 9, and then we have both 5 and 9 in the middle. The median, in this case, is the mean of the 2 middle values, 5 plus 9 divided by 2, which is equal to 7. There are a few things to notice here. First, notice that the median of 7 is not one of the numbers in our dataset. This never happens if there is an odd number of values, but can sometimes happen when there is an even number of values, as we have here. Secondly, notice that the size of the outlier, 150, doesn't have an effect on the median calculation. If we were to recalculate the median, changing 150 to 1000, the median would still be 7. Or if the outlier was changed to 10, a number that is much closer to the other numbers in our dataset, the median would still be 7. The final average to discuss is the mode. The mode is simply the data value that occurs the most frequently. In our dataset of 3, 4, 5, 9, and 9, the number 9 occurs the most frequently, and is therefore the mode. Some datasets don't have a mode, such as this one here. There are no repeated numbers in this dataset of 3, 4, 5, 8, and 9, so there is no mode. Sometimes there can be two modes, such as in this dataset of 3, 3, 4, 5, 9, 9. Both 3 and 9 are considered modes. Datasets with two modes are considered bimodal. A disadvantage of the mode is that it is unstable, as small changes in the data can completely change the mode, or even create a situation where there is no mode. An advantage of the mode is that it can be used on qualitative data, which is not true of most averages. For example, if these were the favorite colors of 5 of your friends, we see that the answer blue comes up the most frequently, so the mode is blue. Let's summarize everything we have talked about. To calculate the mean, add up all the values and divide by the total. To calculate the median, order the data and find the value in the middle, or the mean of the two middle values if there is an even number of values. To calculate the mode, find the data value that occurs the most frequently. An advantage of the mean is that it takes into consideration the size of every data point. A disadvantage of the mean is that it is very sensitive to outliers. An advantage of the median is that it is resistant to outliers. A disadvantage of the median is that only the order of the data is considered, not the size of each data point. An advantage of the mode is that it can be used for qualitative data. And disadvantages include that most of the dataset is completely ignored, and that the mode is extremely sensitive to small changes in the data. Alright, my friends, we have finished our discussion of averages. We will be exploring many more fun and exciting statistical topics that you won't want to miss, so make sure to check out our other videos.